Hey guys, for this lesson, we are going to look at rewriting exponential functions with exponent rules. So this isn't like a formal lesson that maybe would be on the pacing guide for the county. This is something that we've identified as common questions on your benchmarks that are actually really easy to answer, but you just need to take the time to go over these types of questions. So you'll see probably similar questions on EOC benchmark, where they're going to give you an exponential function and they're going to say which of these is equivalent or select all that are equivalent. And so we're going to take just like a timeout here, really quick, short lesson. There is practice on Delta Math about it, so that's fantastic. And we're going to look at how to rewrite our exponential functions using those exponent rules. So if you need any kind of review on exponent rules, let me know. The two exponent rules that we're going to focus on are listed right here. So these basic exponent rules, the first one being the power to power rule. So if I have a to the m raised to the n, if I have an exponent raised to an exponent, that's called the power to power rule. And you take those exponents and you multiply them. So power to power, super powerful, you multiply it. So we're going to use that rule. And the second rule we're going to use is if we had a to the m times a to the n, notice those are same bases. A's are the base on both. Then I can combine their exponents and just add them. So just a quick example as a reminder, maybe if it was like 2 to the third times 2 to the fifth, it would be 2 to the eighth kind of thing. But we're going to be working backwards. Let me throw another example over here. Maybe if this was 5 squared cubed, you would multiply and get 5 to the sixth. And of course, the same would work if the base was an exponent or if the base was a variable. All right, so let's look at these examples so I can give you a little more substance what we're working with. Let me scoot this up. Number one, the number of views of a viral video can be modeled by the function L of n equals 700 times 3 to the 2t. 2t is our exponent there, right? An equivalent function in the form of L of t equals a, so some kind of coefficient. You can have a coefficient number right there and then have a base with an exponent. So the only thing we want to get rid of this 2t piece. We want to kind of simplify that down. So what we can do is take L of t. I'm just going to write my original problem. Okay, original problem. I'm going to apply the first exponent rule, this first one. I'm going to move backwards because see right here in my exponent, this is 2 times t. So I'm going to go backwards where up here in the rule, it's m times n. I'm going to break it apart. I'm going to show L of t equals 700. I'm going to have 3 squared raised to the t. So all I did was it was being multiplied. I worked backwards on the power to power rule. So now it's 3 squared raised to the t. Then you can just evaluate the 3 squared is 9 raised to the t, and that fits the form that they wanted. 700 would be the a, 9 is your b, your base, raised to the t, and we're done. Okay, so this could be an EOC question or a benchmark question where they would have multiple ones, which one's equivalent. Let's move on to number 2. The number of bacteria in a lab experiment can be modeled by the function S of t equals 45 times 3 raised to the t plus 1. Write an equivalent function of the form S of t equals a. So still I can have a coefficient. I'm going to switch colors here. I can still have a coefficient number, then a base to my exponent. Let me just write my original problem. On this one, notice our exponent's a little bit different than the last problem. Our exponent this time has some addition going on. So I'm going to be looking at this second rule. So I'm going to work backwards. Instead of it adding, I'm going to separate them into two powers with the same base. So S of t equals 45. I'm going to have 3 to the t times 3 to the first. So I took that rule of same bases, powers being multiplied together and they're adding. and went backwards. They were adding. I wrote them as two separate. And now I'm going to continue to simplify. So S of t, still have 45. I'm going to bring this over here first, 3 to the first, and just have 3. And then write 3 to the t. So it kind of starts to fall into our formula or our format. So I have S of t equals, I'm going to take the 45 and the 3 and actually multiply them, because the form that they want up here, I only get to have one A coefficient, a whole number coefficient. So I'm going to go to my calculator here, basic calculator, 45 times 3, 135 times 3 to the t. And that fits the form that they wanted, an A coefficient times a base with an exponent. So that is my answer. Number 3, the amount of revenue for a business can be modeled by the function W of t equals 7,200 times 3 raised to the 2t plus 2. Write an equivalent form of W to the t equals A. What color do I want to use? Green. A, so I get a coefficient whole number, and then I want a base with an exponent of t. So let's write our problem. 7,200 times 3 raised to the 2t plus 2. So again, I've got the addition, so I'm going to work backwards. I'm going to separate them. They have to have the same base. When you're working with exponent rules, it's got to be same base. So I'm going to have 3 to the 2t times 3 squared. Again, I'm going to bring this 3 squared to the front, because eventually it will multiply with 7,200. So that is 9. I'm going to go ahead and evaluate that. 3 squared is 9 times 3 to the 2t. Let's see. I've got 7,200, calculator, 7,200 times 9 is 64,800. Multiplied 7,200 and 9 together. And then I still have 3 to the 2t. So I can keep going. I can apply the other rule as well here. So I can have 64,800 times, go ahead and evaluate 3 squared. Let me show that here. 3 squared raised to the t using that other rule. And 3 squared would be 9, and 9 will be my base. Let me give myself some room here. 64,800 times 9 to the t. That's going to be my final answer. Final answer. Again, just applying those 2 exponent rules and working them backwards. Let's look at your last one, number 4. The value of a car that depreciates over time can be modeled by the function m of t equals 18,000 times 9/10 raised to the 2t, or an equivalent function of the form m of t equals a, one single coefficient, numerical coefficient, and then b raised to the t. What do we got? Let me write my problem. 18,000 times 9/10 raised to the 2t. Okay, so I'm going to separate my 2t using my power to power rule. Instead of multiplying, I'm going to separate like so. Backwards power to power rule. And then evaluate 9/10 squared is going to give us 81/100 to the t. And that's your final answer. M of t equals, done, because you've got your 18,000 is your whole number coefficient. That serves as your A in the form that they want. And then we've got 81/100 as our base raised to the t. Final answer. Okay. So again, this isn't like a big major concept in Algebra 2, but it plays on a lot of pieces that we talk about. Exponent rules, we reviewed that earlier in the year. We work with exponent rules throughout the curriculum. 2, exponential functions. So all of these are exponential functions. Notice all of the exponents are my variable. So I think benchmarks, EOC, they pull from those 2 concepts, exponent rules and exponential functions, and they give you these situations where they're going to give you a function and say, which one's equivalent or select all that are equivalent. So for us, trying to navigate those benchmarks and those EOCs, this is worth our time, taking a little bit, taking one day of our lessons, working through Delta Math. So if you have questions, let me know. It does just go back to those two exponent rules. There's a total of 6 different types on Delta Math on this topic, but through these 4 examples, we've covered just about all of them. So reach out to me if you have any questions. Give those a try, and I'll see you later.